Students, this video will kind of review how we set up our Google Sheet to analyze our velocity data. So if you take a look at the screen, you'll see that I've already got my columns named like we named in class, and I've already got my times entered into my data. So if you're stuck at that point, maybe talk to a friend to get you to this point here with your data loaded in. First thing I'm going to do is use the average function to calculate the averages for these three trials. So, like I mentioned, we'll click the box and use the equal sign. And as you can see, it's already guessing that I want to take the average of those. But just so we can show how it's done, you take equal sign, start to type the word average. All right, yeah, I want to choose average. Again, it's guessing the correct boxes that I want to average, but I'm going to do the long way. Now with the open parentheses, it's asking me which boxes do I want to take the average of. So I'm going to click and drag and select these three boxes, trial 1, 2, and 3, and I'll hit enter. And we can see that this box here is doing this function, taking the average of boxes B2 through D2. Again, I'll hit the equal sign. This time I'm going to take advantage of this intelligent guess that it's making here. Yeah, I want to take the average of those boxes, B3 through D3. Enter. And the last function of sheets that I want to highlight here is using the Smart Copy dragger here, this little tiny box. If you use that and drag it down, it's going to intelligently copy whatever is in that box. So it can predict sequences, it can do a lot of things, this little intelligent box. But right here what it's doing is adjusting this average function for each of these rows. So see, this one is doing B7 through D7. So that's a nice time saver. You don't have to calculate all those rows. So the next thing we're going to do now is create our chart. So I mentioned you want to select just your chart, and whatever's on the right side will be on the vertical axis, whatever's on the left side will be on the horizontal axis, and we want time to be our independent variable. That's why I've got position copied over here, so it's on the right side. And then I'll use the create chart, insert chart button, and that's going to analyze the data and create a chart. Now this is a column chart. It's not the right kind of chart for this type of data. So over here in the editor, under chart type, I want to scroll down and choose a scatter plot. Oh, that looks like a position versus time graph, except there are no labels, so we don't know what kind of graph this is. So I'm going to come to customize, and I want to name the chart, and I want to name the axes. So I drop this menu down, and right here I'm working with the chart title. Let's call it constant velocity. Velocity investigation. Great. And you can see it puts it right there. If you want to mess with the fonts or the colors or the positioning, you've got the normal options down here. Now I'll use this drop-down menu here to change to horizontal axis, which is time in seconds. Good. Time in seconds. And now I want to name the vertical axis, which is position, and that is in meters. There we go. Now this chart has a name. We know what we're looking at. It's very, very appropriate. Any chart that you submit, any graph, must have a title, and the axes must be labeled, or it's basically just dots and lines. Not helpful. So the last thing we're going to do is use Google Sheets to analyze this data for us. So we're going to use the series option, and the first thing we're going to ask it to do is draw a best fit line, also known as a trend line. So here's the option for a trend line, and you see it draws that line. It's currently drawing a linear line, a straight line, You can choose any of the types of function here. Right now we're working with linear functions, straight lines. And you can change the color. Might as well make it cool. Make it dark. Cool. Make it thick if you want. Notice my data points aren't exactly on the line, but it's very close. So now the last thing I want to do is a statistical analysis called the R-squared value. And I'm going to use this analysis here. And within this R-squared value, I'm going to choose use equation. So now what we're looking at is, first, here's my equation, and this is the equation for a straight line, which is y equals mx plus b, where m is the slope of the line, and b is the y-intercept. Notice my y-intercept is very near 0, which is good. It should be close to 0. My my slope in a position first time graph is the velocity. Slope is rise divided by run. In a position first time graph, you have position divided by time. Change in position divided by change in time is the velocity. So what we're looking at here is the velocity, 0.343 meters per second. The last thing I want to mention is this R value. The closer this value is to 1, these values range from 0 to 1. The closer this value is to 1, the more close our data matches the line type. So our data very much seems to be a linear data, which makes our R value very close to 1. If it were close to 0, we could conclude that our data was random, which would be due to some sort of measuring error or something went wrong in our data collection. But since our R-squared value is very close to 1, there's very little randomness in our data, and it matches the type of function that we think it should. So anything above 0.93 is an acceptable R-squared value. If you get below a 0.93, you're going to need to, not in this experiment, but in future experiments, you would need to re-examine your experimental design and your data collection, because that means your numbers are kind of random. They don't follow the expected outcome. All right, this is the video. Thank you.